A lift is moving upwards. It accelerates from rest with uniform acceleration 0.4 meters per second until it reaches a speed of 2 meters per second. It then travels at this constant speed of 2 meters per second for 17 seconds before decelerating uniformly to rest in 8 seconds. Calculate the time taken for the lift to reach a speed of 2 meters per second. Sketch a velocity time graph for the lift's journey. Find the distance travelled by the lift during the journey. A man of 70 kilograms is standing in the lift during its journey. Calculate the greatest value of the reaction exerted by the floor of the lift on the man during the journey. So here's all the information. Here's the lift. It starts from rest. It accelerates at 0.4 up to a speed of 2 meters per second, continues at that constant velocity for 17 seconds, and then it decelerates to rest in a time of 8 seconds. So calculate the time taken to reach 2 meters per second then. We've got the final velocity, we've got the initial velocity, and we've got the acceleration. So we can use the equation of motion v equals u plus at gives, in this instance, the final velocity is 2, the initial velocity is 0, the acceleration is 0.4 times the time. So there's 0 there, so 0.4 from times down to divide, 2 over 0.4 is 5. So t equals 5 seconds. So that's part A. So we can put that in, that t in this part here is 5 seconds. Now, sketch a velocity time graph. So I'll do a quick sketch with this digital pen then. Over here. So let's just do a quick sketch. Okay, so it starts from rest at time t equals 0. This is the velocity. This is the time. This is the origin. So v is 5, 17, and it was 8, wasn't it? So that's a total of 30. So let's do 10, 20, 30. The velocity increases to 2 as a maximum, doesn't it? So let's just put 1 and 2 here and here. So it starts from rest here, and then accelerates 0.4 for 5 seconds. It gets up to a speed of 2, so at 5 it reaches 2. So because I've got a digital pen, I'll draw a dashed line rather than a straight line. So there's that coordinate. Then it continues on at 2 for the next 17 seconds. 5 and 17 is 22. So it carries on at 2 meters per second. And then the last 8 seconds, it descends to 0, stops, comes to a, decelerates at a uniform rate until it gets to rest after 8 seconds from here. This is 22. Okay, good. So that's the velocity time graph then. Find the total distance. So this is part B. C, distance, total distance is equal to, well, if you look at this, you've got the area. So this area, you've got this area, and this area here. So the first area, A1, A2, plus A3. So let's put that down. A1 is half base times height. 5 times 2, half times 5, the base. Half times the height, which is 5, times half the base, 5, times the height, which is 2, plus the area 2, which is a rectangle, 2 times this length. 5 to 22 is 17, times 2, plus half, triangle again, base is 8, times the height, which is 2. So just squeeze it in there. So it equals 10 over 2 is 5. 34 here. And this is 8 here. So we get a total of 39.47 meters travelled. So that's part C. 70 kilogram man in lift. Man is in the lift. Find the greatest reaction force. Well, the greatest reaction force, if you think about it, the man is here. The greatest reaction force will occur here because there's a positive acceleration. So R needs to be greatest here. The force acting by the man, the weight of the man, is 70 G. So in part D, we can just say that here R, which is the resistance force, minus 70 G, is equal to the mass, 70, times the acceleration, 0.4. That's equal to 28. 74 is a 28. So R is equal to then 70 G plus 28 newtons. Tap it in the calculator. 70 times 9.8 plus 28 equals 714 newtons. When it's travelling with uniform velocity, here in this middle section, R will equal 70 G, and when it's decelerating, R will be less than 70. So this will be the greatest value for the resistance in part A.